I'm Team No Sleep from the University of Hawaii Hilo in the program representing today's REST, Restoring Ecosystem Services tool. The native ecosystems of the Big Island of Hawaii are found nowhere else in the world and is in decline due to human activity, alien plants and animals, and disease over the last century. For instance, a new disease has killed large numbers of ohia trees on the Big Island. The ohia tree is a key species, meaning without these trees, the ecosystem will suffer, and this is where REST comes in.
Our goal as Team No Sleep is to support researchers rebuild ecosystem functions to their original state. Our program is designed to help a researcher find replacement or complementary species to fill the hole that is left when a keystone species is lacking, such as the Hilo trees in Hawaii. The problem with introducing new species to new ecosystems is that the new species may become invasive to the ecosystem. To mitigate this problem, our program creates a principal component analysis graph. This graph will visually represent relationships between all species in an ecosystem, allowing for a researcher to view the results of their actions without waiting for the results, nor using man-hours to remove any problematic species brought in as a solution. We will now demonstrate how our program will accomplish this goal.
Here we have the alpha prototype of REST, a Windows Form application developed in Microsoft Visual Studio. So in addition to just general restoration, REST also supports specific restoration goals, such as fire tolerance and water allocation. By selecting one of these restoration goals, we can restrict our list of traits that we're looking at to only those traits related to our restoration goal, such as fire tolerance. So in terms of managing data, REST has two main methods of doing this. The first is with databases. REST uses databases from around the world. To demonstrate this, notice that we have various plant species from these databases, as well as a multitude of plant traits. The second method that REST uses is to allow the user to use their own data. So that we can use the import database tool, and the user can select their data file, and by doing so, now we have the user's species that they want to use. And by selecting one of them, we can now see the associated values for each of these traits. REST also supports the ability for the user to also change the data as well. So they can change the value of altitude range from 1200 to 1300. Now let's just select a few of these traits and we will perform an analysis. So as you can see here, we have a PCA, or a Principal Component Analysis graph. What a PCA graph does is it takes this complicated high-dimensional data and it transforms it into an easy-to-read plot where we can see how different species are related to one another. So for example, take species number 18. Suppose this species was declined in our ecosystem and we want to supplement this species in a way that we maintain ecosystem function. Notice that species 13 is very similar to species 18, so it would be the best candidate to do this. Moving on to our analysis tab, we can also get more numeric information related to the PCA graph. In addition, we have a dynamic explanation system to guide the user so that way they can interpret these values and interpret the graph so they can choose the species that best fit their goals.
While REST is used primarily as a restoration tool, it can also be used for other methods, such as the prevention of natural disasters, such as forest fires. It can also be used for plant compatibility, as well as a general tool for the promotion of growth in an ecosystem. Previously, this type of work would have been done by biologists and consultants, but with REST, we can do the same work faster, more efficiently, and with additional information. Our target customers include large landowners, such as farmers, ranchers, resorts and hotels, nurseries, as well as government agencies, such as the Department of Forestry, military compounds, as well as university researchers. While the program itself will be released for free, we do have models to get revenue off of this project. including paid consultation, training, setup, as well as the creation of plant ecosystem portfolios. These portfolios will serve as a profile of all the plants, traits, and related information in an ecosystem.
In conclusion, we believe that our program REST is suitable for the World Citizenship category due to its potential global impact. Thank you for your consideration.